So we're continuing on with the die class example, and we're going to look at some additional methods. We're going to look at the constructor as well as the toString method. As I mentioned, the toString method is very important. It's actually a very interesting method to look at, and also the purpose of the constructor and how that actually works. So if we look at the die class itself, we'll go back over to it in the code. We will look at it here. You'll notice that it's pretty simple in terms of a declaration. We've got public class die. There is no main method because this is a class that doesn't run on itself. It actually requires it to be used within a program that has a main in it. So this is the actual program that executes. So the question is, of course, where is this? Where are the class files? Where is everything getting compiled to? So when you hit the compile button for the Snake Eyes program, it compiles it nicely. When you hit it for the die class, it also compiles it. But when you run the Snake Eyes program, it declares the two die objects quite nicely. But some of you might be thinking, aren't we missing something like this? If we're going to use the die class, shouldn't we be importing it? Just like we do the random class, the scanner class. There's other classes where we don't. For example, the string class or the math class, those are automatically imported. But the string class and the math class are part of the standard Java library. We don't have to import those, but why do we have to import the scanner class and the random class, even though those are part of the standard Java library? Well, there's a lot of reasons why something is or isn't imported from the standard Java set of classes. But in this case, we don't need to import the die class because if we look at where the files are located, you'll see in this folder, I not only have the Snake Eyes program, and it gets compiled to a snakeeyes.class file, but I also have the die class. The die class is also within the same folder. And Java has a rule that if all the classes that it needs are in the same folder, in the same directory, i.e. the same location, you don't need to do any special imports. You don't have to do any additional declarations. Java will be able to find it. Essentially, everything is in the same room. Java doesn't have to go looking for anything. So that is why we can go ahead and just use the die class here without actually have to have it being within a separate location, and we don't also have an import statement either. So that is how that works. So I want to take a look at the constructor and the toString method. So if we go back over to the die class, we have the constructor here, and we also have the toString method over here. So if we look at the API, we see that the constructor sets the initial face value of the die to 1. So when an object gets constructed, when it first gets created, when it comes to being, it gets a value of 1 for the face value right away. That's the purpose of the constructor. When does the constructor get called? Gets called only when the object gets created. So whenever Java has to create a die object in whatever form, and we're gonna explain what whatever form means later on. But for right now, what we mean is if you look inside the Snake Eyes, when this gets called here, you can see the syntax for the constructor. So we're saying create a new die object, and we're just using the name die because that's the name of the class. We're going to create the object in memory, and then that memory address is going to be returned back and stored into die1. Die1 is a primitive variable which holds just the memory address, and it points to a memory address which has a die object, so all the attributes and methods that belong to the die object. So then we've also got the other special method, which is the toString. So toString, it's a very weird name, but toString just means take the object and convert it to a string and return back a string. We're going to talk about what it means to convert to a string in just a moment. But let's take a look at that constructor. Let's take a look at that constructor that we've got in the die class. So let's zip up here, and we can see that it's doing nothing more than just setting the face value to 1. And because the face value is within the die class, which is its attribute, there's nothing special we have to do. We just say face value and we set it to 1. So let's open up a very simple program, and we're going to just look at doing some simple die class manipulation. So simple die roller. We're just going to create a brand new file here. And maybe I should create it instead of trying to just open it. So let me just do that one more time. So we'll call this one simple die roller. There it is. We are going to declare it. And this one is also going to be a program class. So and as we saw with the Snake Eyes program, we don't have to do anything special with loading in the die class because this file is going to be saved in the same folder, the same directory as the die class itself. So we'll be able to just open it up and use the die class. So there we go, just going to do a save. I always like to do a little bit of a compile perfect. Program doesn't do anything yet, but it's always good just to make sure the compiler is working. So simple die roller.java, play with the die class. So that's all we're really going to do here. Excellent. So let's create a die object. So die, we'll call it Romeo, just because we can. And it will be a new die object. Now let's take a look at what values within that. So we can say systemout.println Romeo value of face, and we will just get the face of Romeo. So this one should tell us, should have a value of 1. Let's see if I could spell it correctly. There we go, Romeo. And there we go, Romeo value of face is 1, because that's actually what we've got as the constructor. And if we go back to looking at the code, we see that we've created Romeo up here. We've created Romeo, new die. So we haven't done anything else to this die except for create it. We haven't rolled it. We haven't done anything else to it. All we've actually done is just create it, which means the face value is 1. Later on, of course, we do have the ability to set the face value, and we will set it to 4. Now, that just sets the face value of the die. But you'll notice there's no return value or anything. This is a very important moment. What we've done is we've told this object called Romeo, I want you to change your value. I want you to change the face value within yourself. This is an independent object in memory. We can change its value because we have something that lets us do it. We have a method that lets us make that change. So let's go ahead and display that. So Romeo value of face after change. Let's see what happens here. We should see a 1, and then we've changed it to a 4. So this object in memory is actually like a real thing. It got created, it got that initial value. Now we've just changed the value. We didn't have to roll this die. It's as though I was holding it on the table. It had a value, face value of 1, and then I've just turned the die so that the face value of 4 is now up. So that die itself, if you will, I cheated, but that's actually what I've done. So this is a very interactive object. This die, you can actually have it automatically do things with a roll, or you can just change the value itself. Now let's go back over to the die object and see that we're setting the value to 1, but we actually have that method down here called setFaceValue. why couldn't we have used that value up here? And you know what? We absolutely can. We're going to change the value of the die by using the set face value. We've seen this before where one method can call another method. So within the die class, all the methods can talk to each other. They can actually communicate and make changes to things. So what I'm going to do is call set face value, and I'm just going to set it to 1. So when this die gets created, the first thing that's going to happen is that we're going to come down over here and call this method, which sets the face value. And we pass in the value of 1, that becomes value. So then face value gets that, and it changes it up here. So why did I do this? I mean, it was simple enough just to say face value, set it to 1. And since I'm the programmer, I should be able to be aware of the limits of this. Well, didn't we actually discuss that set face value ensures the value of the face is proper? So it's not going to be anything less than 1 or anything greater than 6. If I was a very careless programmer, I might have actually done something like this. I'm not really caring, so I set the face value to, let's say, 22. So that's part of the constructor. I'm not calling set face value, so there's nothing that says I can't set it to 22. So let's get back over here. I'm going to do a compile, and we'll notice that the first thing we do is we display the value of the face. So if I run it, we should see that it's set to 22. And that is not very good for a die that only has 6 sides to be set to a face value of 22. So what I've actually created here is an opportunity for security. I'm never going to use any other thing to set the value except for set face value. Now for roll, on the other hand, if I look at roll, roll automatically ensures that the value is within 1 to 6. But I could also do something similar here. I could create an internal value, so just local to the roll method. So we'll call it temp face value, and we'll make that be assigned whatever the random number is. And then here I could do a set face value of temp face value. So I'm setting the face value based on that value. If for some reason this got out of alignment, um, instead of a shift of 1, I did a shift of 10 by accident, this would also ensure that the value is being controlled by this set face value down here. So any incorrect value, of course, would not be set properly. And we don't have to change this one because set face value only modifies the face value if it's permitted. So if it was not permitted, if we returned the face value, this would be the old face value. So I've made this class just a little bit smarter. It's just a little bit better. It's got a little more security in it. Let's go back over here to the simple die roller, and just to make sure that our changes haven't modified the class at all, perfect. We're initializing it to 1 again, and then our changing our face value is fine as well. So if we go back over here to the die class, I was mentioning the constructor, and I was mentioning the toString method. But before I get to toString, one thing that we sort of skipped over very quickly is that nothing here is a static. Nothing is defined as static. Yet if we look at the Snake Eyes program, we see that the main method is static. This whole class is referred to as a static class because of that. We look over here to the simple die roller. It's also a static main method. Why is nothing in the die class static? Well, the reason is that the die class, in order to be able to use any feature of it, you have to create an object. So if we go back over here to the simple die roller, I'm going to remove some code. We can't use the die class directly. We have to create an object of it. So we've got the object here called Romeo, which is an instance of the die class. If I tried to do something like this, let's say die set face value of 3, which is a permissible value, this will actually cause a problem when we compile it. So what Java is telling us is non-static method set face value int. So it found this method called set face value cannot be referred from a static context. What does a static context mean? It means that the die class doesn't have anything that can be used without creating an instance of it. You have to create something dynamically. So within programming, something is either static, which means it's permanent, and it almost always means that there's only one of them, or it's dynamic, which means you have to create something of it in order to use it. So if you go back to the example of human, a human itself, it's a totally dynamic class. You can't make a change to a human unless you actually have an instance. So you have a person, you've got Bob or you have Alice. You need an instance of human to start making changes. Same with the die class. There is nothing here that is static. So we can't just use the die class itself. We can't refer to it. So that's why everything in the die class is public and non-static because of that. So I always like to do a little compile there. So we've got our code back to a standard set, but it's a slightly more secure version of it. So let's take a look at um, the toString method itself. So with toString, we can do something really interesting. So let's take a look at this one up here. Systemout.println, Romeo value of face, and we get the face value. But maybe there's another way to display the die itself. How about this form? So I'm going to comment this guy out. We're going to put back in here system.println. I'm just going to say Romeo, leave it at that, and then just display Romeo. So I'm going to treat it just like I do a primitive. I'm just going to display its value. So what is going to get displayed in this sense? Romeo is not a primitive. It's not a string either. So what is it? That's a good question. Well, it's a die object. But by just doing Romeo like this, what does it mean? Well, before we look at the class itself, take a look at this plus symbol. We know that if it's got a string out here, that plus symbol is not going to be addition, it's going to be concatenation, which means the outcome of all of this is going to be some sort of string. So the first string here, which has just the word Romeo in it, is going to get concatenated with whatever Romeo is. So what is Romeo? Well, by definition, it's actually an object. It's a memory address. Well, that's not very useful for us to display that. I want to get some more information. I want to possibly see what the face value is for Romeo. So let's look over here at the die class. So at the very bottom of the die class, we have this method called toString, and the comment returns a string representation of this die. So what is going to get returned? Well, let's take a look at the method header. So it returns back a string. The method is called toString, and it has no parameters. That's actually very important, no parameters. So what we have inside is we're going to declare a local string here called result, and the textbook does something extremely complicated, which is take the face value as an integer, because that's the data type of our attribute, and convert it into a string. Now, of course, we could do it much easier. I don't know why the book did it this way, but we can just say concatenate that with face value. We'll just leave it at that. So this will return back a string. So we're going to get a concatenation with an empty string, and it's going to be just the face value. We're going to store that in a string and then return it. So this method called toString returns that. So let's save it. Go back up over here. And what happens at this point? Well, Java knows that if it needs to treat this object here called Romeo, if it needs to concatenate this with a string, what it will actually do is replace this code as it's executing it with a call to toString. This is one of those examples where the string class is super, super smart. It's almost magical. So in this case, Java knows that it has to do some string stuff with Romeo as a die object. So it's going to call the toString method. So let's just leave toString in there right now. We know from this example over here that the toString method just returns back the value. So if the face value was 2, we're just going to get a string 2. So as a comment here, if the face value was 2, this is going to be represented as a 2. And that's what this statement up here does. So let's take a look at how that will execute. So let's go back up over here. So what we should see is just Romeo, and we're not rolling it, so we should see a Romeo with a value of 1. So let's compile this, and let's see what happens if you type in the command properly. And we'll execute. And there we see Romeo 1. So what Java is doing is it's calling the toString method for Romeo and returning back a string for this whole expression, which is then concatenated with Romeo. But the beautiful thing about toString, you don't actually have to include it when you do the call. What Java will do, because it knows it has to do some sort of string concatenation, it will then automatically call the toString method. So that is one of the coolest things about Java and classes, is this toString method, which you can include and you should include in all your classes, because you can return a string which has a special value. So you can do some really interesting stuff here. You don't just have to return the face value, you can format this information. So you could say the result is the die value, like that. Let's put some extra little formatting around it. We'll put a little square bracket there. We'll maybe put a square bracket right at the beginning. So now, instead of just returning back that single individual number, which is the face value, we're going to get a much longer expression. So let's go back over here. Let's compile this again just to make sure. What is the problem that we? Oh, I'm missing. I'm missing proper concatenation here. So let's put that in. We'll compile this class here, come back over and run this guy. And there we go. So what we have is Romeo. It's just doing that concatenation with whatever the toString method is going to return. And the toString method returns this really complicated die value and the face value, even though we didn't actually put this in the code for when we wanted to display the value. So you can display practically anything, which is whatever you mean by the toString method. So every class has this way of doing it. If we look at the scanner class, it actually comes back with a much more valued expression. So just as a quick example of that, let me include the scanner class here. We will create a very simple scanner, which is just tied to system.in. And let's just display the scanner that we created. So I'm just going to say, let's see, scanner here, scan. So I'm not doing a next, I'm not doing an extent, I'm literally just asking the scanner to display itself. So I'm asking scanner here to display itself. So it's going to call the toString method for that scanner. Get ready for a surprise, because this is what happens when you call the toString method for a scanner. So it tells us what class it's based on, which is that expression there. It tells us what the delimiters are, which is what is the separator for all the strings. So when you do a dot next versus a dot next line, how does it know to stop at the space? or a new line? Well, it knows that the delimiter is Java whitespace, which is a space or a new line. We do a bunch of extra stuff here, which is all defining all that information. We see comma is also a separator. We've got a decimal separator. This is for regular expressions, which you'll look at in the next course, unfortunately. So all the rest of this stuff is just how the scanner class breaks up the system.in stream input. So everything is defined in the scanner class, which is pretty cool because the scanner has a toString method. What if we didn't have a toString method? What if it just didn't exist? So let's go back over here to the die class, and I'm going to comment out all of this here. Let's use the multi-line commenter. That'll be a lot faster. There we go. So now there is no toString method. So what happens if we try and do this display? What are we going to see? Well, I wonder. If we run it, we actually get this complicated die at 1CAC5AF. What is that? Well, Romeo is a die object, but it's properly a representation of a memory address. So this is a memory variable. Well, guess what the memory address is for this die object? It's at memory address 1CAC5AF, whatever that happens to mean for the virtual machine and Windows, because I'm running this in Windows. And we know that what this is telling us is we have a die object at memory location such and such. Java, unless it's told to do something special with toString, its default toString method is to display the memory address of the object. That's really what it does. So it's always good to have a toString method because that memory address is practically useless. So let's put the toString method back in. We're going to go back over to our simple roller, do a compile just because, we'll do a run, and now we actually have some better information. Because the memory address doesn't help us at all with a die. In this case, we can display the die value itself, or the face value of this particular die. So that's how the toString method works. You don't have to include it, but you could if you wish. But the point of calling it toString is so that it's not there. Now there is nothing called toInt or toDouble or anything like that. The string class is magical. It's very special. So you have to use the syntax toString. You can't call it anything else. If I call this toString A and go back over here to my simple roller and compile it, you'll see that I get back the memory address. And it's because Java could not find a toString method. It was trying to use a signature. It was saying, I need to find a method called toString with no parameters. It couldn't find it. So therefore, it defaulted to just showing us the address. So that is the beautiful thing about the toString method. And the constructor. The constructor is called whenever we create a brand new toString object. Just like that. So that's actually pretty cool. So there you go. There is some cool stuff about the constructor and the toString method. For all the classes that you define, you will definitely need to put in a constructor. If you don't include one, Java will put one into the code. It just won't happen to do anything. So in this case, we also have the toString method, which is very useful because we've gone ahead and included it. So that's it for this virtual lecture. I will see you guys in the next one, and we're going to keep talking about classes. See you then.